A given spring with a given value of K and a given value for the mass that hangs on the spring has one and only one period. If I change the amplitude of the spring, that period is not going to change. If I change my definition of t equals 0, which would introduce a value for alpha, that period is not going to change. So omega and p are completely independent of A and alpha. What is the meaning of A and alpha? Well, A and alpha is what we call the initial conditions. The initial conditions. And I discussed one initial condition. If you define at t equals 0, that the object is at x plus a and you release it with 0 speed, then out comes alpha. You could also have released it at t equals 0. You could release it at x equals 0. And you could release it with a certain speed v. You just give it a kick. Well, then out of this information would follow both alpha and A. So that's why we call them initial conditions. Now in our simple harmonic oscillation, which has the form x in its most general form times A cosine omega t plus alpha, notice that this oscillation will go on forever and ever and ever. It will, here is x equals 0, it will reach plus A, it will go back, it will reach minus A. And there never comes an end to this. This is of course not very realistic. In practice there will be damping. That means there will be some form of air friction, and then the oscillation will gradually die out. But we have not taken that into account. It will oscillate maybe many times, and ultimately it will come to a halt. In the problems that I will be doing in this section, I will always ignore friction and air drag of any kind.